Thank you. Hi everyone, thanks for coming. I know it's early due to last night's concerts for those who were there. So welcome, my name is Christophe. I work at Datadog, focusing on cloud security and open source topics. And this is Vlad.
Hi, I'm Vlad. I'm a staff engineer at Datadog. I'm very involved in the Node.js community, and follow me on Twitter if you haven't followed Twitter yet.
Thank you. So everything we're going to discuss is also the work of Hélène Wang. She was an intern at Datadog. She's not here today. She's based in the US, but she was part of this as well. So today we have an agenda. We're going to start with modeling a bit what typically malicious package attacks look like, try to see how we can detect them. Then we're going to talk about a new open source tool that we've released a few months ago called GuardDog. We're going to see how we applied that to try to scan all the new packages on PyPI. By the way, PyPI means the Python package index, in case. And finally, we're going to share some of the findings that we have and some ideas for future research, if you are interested by that. So Vlad, can you maybe walk us a little bit through what a malicious package looks like in 2023?
Yeah, sure. Also, it's worth mentioning the slides are already online and public, and we will give you a link for them. So we asked an AI, because that's what you do now, what a malicious package is, and we got this pretty nice picture. And I think it's good because it looks shiny, but it's scary at the same time, and you're not sure how scary it is. So let's see how scary these packages are. Let's model software supply chain attacks. So if you want to inject malware into someone's code base, you need to find a way to have them install it, right? So you need an installation vector. There are multiple of them. We'll see everything in details in the next slides, not in too much details, I promise. Then you need the code to be executed. You need your malicious code to be started one way or another, and you need your code to run. We will see the difference between those two next slide. And you have a goal. The goal of your malware is to steal something, change something, do something. So let's take the example of the requests X package. So for those who are not familiar with the Python ecosystem, requests is a very, very popular PyPI package that enable you to do HTTP requests. And you've got the request X package. That's definitely a typo squat because the S is close to the X on most keyboards. And if you have fat or sticky fingers, you end up typing an extra letter. Well, let's check what's inside request X. It overrides the install method that's executed when you pip install the thing. So when you pip install request X, it will run the arbitrary command named execute. What's inside execute? Well, conveniently, they decided to tell us kind of what they were doing, that we write remote access.py on your disk, which is weird because it's not a remote access script, and execute it in a sub-process. That's what we have at the bottom with sub-process.popen remote access.py. So what's in remote access.py, you ask? That's a very legitimate question. Well, it will actually steal the cookies for Roblox, which is an online game in browser that some people use for crypto stuff, of course, always. And it will steal your cookies and post that into a Discord server. So what we can see is that it's a very, very modern attack, stealing cookies for an online game and posting on Discord. The hacker is very hype. But at the same time, we see that their goal is stealing your Roblox credentials. So because we are security researchers, we want to build matrices. Here is a matrix where you can have some of the things we have seen in terms of vectors of installation, execution of code, and objectives. And if we are looking at the request X package, you see that it follows a very standard path in that situation. So how likely are you to download malicious packages? That probably the topic of the talk, but it's fun to mention that you can buy legitimate PyPI maintainers account on the dark web. Please don't do that. But they are available to purchase. And there have been also some phishing attempts to steal people credentials on PyPI to be able to publish package on their behalf. So you will get a very serious email telling you that Google requires you to do something. And you can get to a clone of PyPI. To a clone of PyPI where you will put your username and password. You can note that if you use a password manager, the password manager will not detect this website as legitimate PyPI. The site that is on site.google.com might be the reason. But how do we detect this malicious package now?
Yes, so that's more for how we model this. So now a few things about what we want to detect. If you know this pyramid, sorry for that. But basically the point is that we are trying to detect more behaviors and tools as opposed to detecting hashes and IP addresses. Because typically for an attacker, an IP or a hash is going to change very quickly. Whereas if you want to detect behaviors and attack techniques, it's going to be much valuable in the long term. So we are going to focus on behaviors and tools. More precisely, if we look at the example we had before, there are a few quick wins that we can look at. So obviously, the request X package, it has a keyboard distance, maybe a Levenstein distance very close to a popular one. We see it has an empty description on PyPI, which by itself is not malicious, but it can be marked as suspicious. We see there is this command running automatically when you do a pip install. There is also writing something to disk and executing that. And finally, reading your cookies, which most likely Python packages should not do in general. So that's a few opportunities for detections. That's for the what. In terms of the how, so we can do static versus dynamic analysis. Let's say we want to show when something is downloading a Python code and then, a binary and then executing it. So we have two ways, right? With static analysis, you're going to look at sequences of source code. You're going to say, whenever I get a request.get followed by a file write and then a subprocess.popen, I want to match on that. So here, the good thing is that it's very easy to write. If you're able to write source code, you can write that. It's more sensitive to false positive and to obfuscation. And if you want to write something good, you need to write very wide rules. So here we have request.get, but we'd also need to do request.post, url-lib.open, etc., etc. Dynamic analysis, you're looking at the OS level, so, system calls, things like that. It's harder to write, slower, you have to run untrusted code, which typically isn't great. But it's library agnostic, so you just need to say, I want an HTTP request, you don't have to write it for specific languages or libraries. So that's maybe the two ways that we can do it. So in the case of the tool that we are going to present, which shows only static analysis for a few reasons, but mostly because it's easier to write the rules, it's faster to run. So for developers, it's actually easier to use, and you don't have to deal with how do I run untrusted code on my machine thing. So before we come up with a solution, let's try to define a bit the problem space. So we want to look at both the package metadata and the package source code, because as we saw in the metadata, we have some interesting hints as well. We want something that is easy to use. It should be just a command. I don't want to have to run any VM or container or cloud infrastructure. The rule set should be open source. Obviously, you don't want to run some kind of black box. You don't know how it works. And we want it to be CI friendly. So as a developer, it's good if you can run it inside CI every week and get an alert if you see that one of your dependencies might have been compromised or is malicious. So I stole this table from a very nice paper written by Vu Dukley and several people from ChainGuard. They basically list all the available solutions they know as of September 2022 to detect malicious Python packages. If we filter that on things that publish their rule set, we have this. So we have Bandit Formal, which is a fork of Bandit, a Python static analysis tool. It's a fairly niche option. It has like 4 stars, I think, on GitHub, and it's not very maintained as far as I know. OSS Gadget is published by Microsoft. It only works on the package source code, and it works with regexes. So it's good, but not perfect, and they say themselves it's very prone to false positives. PyPI, they also have a set of malware checks. So when you upload a package, they are running some rules to make sure it's not malware, but it's fairly minimal, because obviously they cannot afford false positives, and it's only meant to be used in the context of PyPI, so you cannot run that on your machine. And finally, there is TypoGuard, which is more meant to detect typo squatting, so it's a very specific set of issues. And there's also this project, Packagey, that was published around the same time of Guarddog. So it's a PhD project from someone, and they are doing both static and dynamic analysis. I think it's a very interesting project to follow. Right now, it seems that it's pretty prone to false positives. We tried to run it on a few packages, popular ones, and every time it says that they are malicious. So I think it's a very interesting approach, maybe for the future, and it's going to be complementary with the tool that we present here. So Vlad, can you maybe tell us a bit about Guarddog?
Yes, so Guarddog is this tool we built at Datadog internally. It's fully open source and self-contained, which means you install Guarddog, you get Guarddog, you don't have to update a database, you don't have to install external dependencies, you pip install Guarddog, you get Guarddog. It supports PyPI, and NPM starting January, so 2 months ago. NPM is a JavaScript repository where you can find all the JavaScript front-end and back-end malware. The other big advantages of Guarddog includes having a very cool logo. We have stickers, you can ask for them. And please go star the GitHub repo. We need that as social validation and ego boost. So, joke apart, how does Guarddog works? As we mentioned, we are interested into knowing what happens at source code level to find malicious patterns, but also metadata. As Christophe said, there are a lot of hints when you look at the metadata of a package to know if it's trustworthy. So, Guarddogs compile these pieces of information and make it a wall to give you a report. So, for the source code analysis, we are relying on something called Semgrep. Semgrep is an amazing open source static code analysis tool. For the French people out there, it's written in Camel. It's traditionally used to find vulnerabilities. If you check the rules written by as a company behind Semgrep, they will focus on finding vulnerabilities in code base. But we can tweak it. We can write our own rules to find malicious code instead of vulnerable code. And it provides taint tracking capabilities, which is brilliant when you want to detect malware, understand what code does. Last but not least, it's transparently packaged with Guarddog, meaning that you pip install Guarddog and Semgrep is installed all by magic on your machine. So so one of the big advantage of Guarddog is that when you're like me and you don't know to write regexes, you don't need to write regexes because this is a rule file for Semgrep. Sorry, I said Guarddog, I meant Semgrep, where you can just define patterns in a very friendly way, very maintainable way. So in that case, what we are saying is we want to find all the subprocess.popen and all the os.system call in files that are named setup.py. And it's as straightforward as this. I've seen people frowning when we told about taint tracking, but that's how Guarddog works, so let's take a look. You can define what's called sources, which means I am looking for code that gets out of one of these functions that match this pattern. And this will be my sources, my inputs. And I will track these inputs and their changes until it gets to a sink. In our case here, we want to track everything that gets out of os.getEnv to get environment variables and to see if they are pushed on the network with request.post, not requestx, request.post. That would tell us that someone is stealing environment variables. Let's take an example. Here we've got credentials getting out of os.getEnv AWS secret access key, probably something we need to keep secret, and we put it on the network with a post request. Well, Semgrep will be smart enough to detect the link between the two. But Semgrep is even smarter than that, is that it can taint track transformation on the source to the sink. So here we've got the variable cred that is marked as tainted. We base 64 encode it, so Semgrep will say that encoded is also tainted. Then we concatenate it with a string, and Semgrep will know that it is also tainted. So at the end of the day, we are able to know what goes into the sink and that it came from one of the sources we defined. Regarding metadata, they are written in Python, so you can, if you can read Python, you can read them and update them. They are directly into Guarddog's code base, which is open source and public on GitHub, and it's based on PyPI's metadata or NPM metadata for the NPM support, and it will highlight issues in package health or potential installation vectors. For instance, we detect something that has no description on PyPI. We detect something that has a name too close to a very popular package to find potential typo squats. So, yeah, it renders properly. If you run Guarddog, it's really straightforward. You do Guarddog PyPI scan and the name of a package, and it will tell you our Guarddog findings for this one. So, you can't run this command anymore because the malicious package has been taken down from the PyPI repository, but run it on any currently known 404 packages, and you will find a report with these kind of things. It's very straightforward to use even for developers. We've got the verify command that you can run against a requirement.txt, meaning it integrates directly into the tooling developers use today. And it plays very well with GitHub, because if you put it in a GitHub action, the report will be consumed by GitHub, and they will tell you this dependency shows something malicious, and thanks to GitHub features, you can dismiss if it's a false positive you don't want. Now that we demonstrated that we have the coolest malware detection tool in the world, how do we use it at large?
Thank you. Yeah, because mostly for now you could have known everything from the README. So let's maybe get into the interesting parts. So that's for the more developer use case, right? You're a developer, you're developing something, you want to know if your dependencies are malicious. Now we are working as security researchers, so we also want to be able to find something new and continuously scan everything we have on PyPI. So PyPI is making us available two RSS feeds that are very convenient. So one is for the new packages that get uploaded, and one is for the existing package that gets some updates. So it's RSS, so it's very straightforward. You just have an XML that you need to parse. You get here the latest package that was published on March 15. It was Astro Toolbox, so you can then go to the link and you can use the API to get the source code and the metadata. So at a high level, what we want to build is something like this. We scrape the RSS feed. We put the new packages into a scanning queue. From the other side, we have something that's going to use guarddog, scan that, and store the results somewhere. We did the implementation with AWS, so we are doing this with a Lambda function running every 5 minutes, scraping that, storing the packages in a DynamoDB table to make sure it doesn't get scanned multiple times, scanning that into a queue, and then we have another Lambda function that's hooked up to the queue, and that's going to scan that and store the results into DynamoDB for the scan results and in S3 for the actual source code. And I promise the S3 bucket isn't public yet. So in terms of scaling, this has the nice property that if you hook up a Lambda function to an SQS queue, actually the scaling is going to be managed automatically. So if you have nothing to scan, you pay nothing basically. And when you start having things in your queue, AWS is going to add these Lambda functions and to connect them to the queue automatically, up to 1,000 functions in the same time, which is much more than enough. So obviously we are trying to monitor that, so we are doing this with Datadog. So we are tracking the number of packages that we scan. We can see it's approximately, so this is over the last 2 weeks, so it's approximately 25k packages per week. We are monitoring the scan times to make sure that nothing is too slow, so the median is approximately 6 seconds. And some metrics as well on the infrastructure, like when you get a package to scan, how much time does it take to get it to be scanned? Okay, so I think there are a lot of security engineers in the room. So you probably know that when you run a tool and you get the scan output, the job is not done. It's actually just the start. So we have an internal process where we have a web UI hooked up to the DynamoDB table, to the S3 bucket, where people internally can go look at the packages, look at the guarddog results. And so here you can see we have the guarddog JSON output on the right, the source code of the package on the left, and manually we go ahead and we say, okay, this package is malicious. Because obviously there are some false positives and we don't want to mark automatically some packages as malicious. We don't want to report them to PyPI, if they are not malicious, etc. There is also one dataset that is very interesting for triaging and for finding malware. It's, a BigQuery, so it's a Google BigQuery on Google Cloud dataset that is public, made available by PyPI, where you can basically use SQL to query all the metadata of all the packages. And we see that in an example, but it's very useful because when we find malware, you can go ahead and say, okay, show me all the packages with the same author or with the same description or with similar properties. We'll see that in a bit. Now, in terms of results, so long story short, there are actually quite a lot of malware every day. This is the graph for the last 2 weeks. And you can see that every day we manually mark some things as malicious. So obviously not all of them are state-sponsored actors or things like that, but we see malicious packages every day. That's an interesting fight for us because initially we thought that we'd have some things, maybe once a week or not all the time, but it's actually more frequent than usual. Disclaimer, there are also some security companies that upload some packages as sample malicious code, but it's a minority. So we see things from script kiddies. We see some code that doesn't even compile, to things that are more elaborated and some backdoors that we'll see in a bit. And one thing that we notice is that it's actually pretty hard to analyze that because you get a flow of malicious packages every day. And how to analyze that is a bit challenging because you don't know if something you see is something you have already seen before. So we try to come up with an approach to do some very simple clustering of the packages, where the goal is to say, okay, I have this new package. Does it look like something I saw or I analyzed before? And it also allows you to see when you have similar packages. Typically, they are made by the same person, by the same actor, or maybe targeting the same kind of victim. So the issue is that it's not a trivial problem. And here you have the papers that are implementing a proper solution to it. This is not what we're going to see now. So what we're going to show is something, let's say, that is good enough, that we developed and that we think works well enough for the use case, but please don't do this at home. So basically what we are doing is we are looking at the abstract syntax tree of each file in the package. We are extracting some of the features from that, and then we are feeding that into a clustering algorithm called HGBScan that we selected thanks to GPT-4. So basically, the way it looks is that you get initially some source code, you convert that into an abstract syntax tree. It's not pretty, but it's much easier to work with. We extract some basic features from that. Again, don't do this at home, but we are looking at the imports when there are some assignations. If there are some for loops or while statements, we put that as well. And then we feed that into the clustering algorithm, and we get something. So you can see here we have a big cluster in the middle that corresponds to someone that uploaded a batch of hundreds of malicious packages at the same time. And if you zoom in, you will see also some other clusters that correspond to very similar packages. So that's very helpful. And today, so we are also open sourcing something new. As far as I know, it's the largest open source dataset of malicious Python packages. So it's right there, made public 2 hours ago. And basically every package that we mark as malicious, is going to be published there. And the goal is to make it available for anyone to use if you want to develop your own detections, clustering algorithm, if you're just interested to see what real life Python malware looks like. So it's all a zip file. There is a script to extract that to your machine. Please don't run it. It's malware. So please use it and abuse it. And if you have some feedback or request, feel free to ask. Now, a bit of more in practice, what we found. Vlad is going... There's an image missing.
Yes, the image is
Vlad is going to show us a real-world backdoor that we found a few days actually, after releasing GuardDog.
Yes, thanks. So we published GuardDog and we started to scan at large every day, what Christophe explained. And we found this package being published named FastAPI Toolkit, updated actually. So for those for the Python ecosystem newbies, FastAPI is a framework that people use to build web application with. It's the equivalent of a Java Spring, of a Node.js Express, or a PHP Laravel. So this package was created in March, and it's an interesting one because it's a package that contains a lot of toolkits for FastAPI, including bringing an APM, database connections, all those kind of stuff. So it's a collection of utils you can add to your FastAPI application. So it was published first in March 2022, and it was kind of nice with all those goodies inside, poor documentation, but that's okay. And on November 23rd, there was a backdoor that was published in an updated version. So basically what was the backdoor? There would be an exec base64 string that was imported from another file. So let's check the malware code itself. It's this base64 string. And if we unbase64, we realize that this code actually adds a new post endpoint to the application. And this post endpoint, if you have the right token in the headers, it will give you a Python shell access and a database shell access. So if you know the token and the URL of a server using this package, you can run arbitrary Python code or arbitrary SQL code on the production of these people, which is a bit scary. So what happened? Maintainer reverted the malicious commit because it was even committed on GitHub. Like they did not even try to hide it by only publishing it on PyPI and not GitHub. They reverted the commit on December 22nd. There was an issue not opened by us, but opened by someone else, saying, hey, there's a malware added in a recent commit, and the issue has been deleted. You can't find it anymore. So we think that either the maintainers has been compromised in their account, or they went rogue, maybe. Well, maybe I lied on the previous slide. You can't find the commit again, the issue again. So they say that they added it for educational purpose. I've got a very long conspiracy theory, and we don't want to get sued if I said it publicly, but feel free to reach out after the talk and I will tell you what it is. It involves stuff that might have been happening in Eastern Europe since last year, if you know what I'm referring to.
Thanks, Vlad. And maybe now something a bit more basic and a bit more typical that we've seen a lot. So we're going to look at a package that we found just a few days ago. It's called TLS Python. So let's see what it does. First thing, it's going to run a command that's going to take some code from pastebin or something similar and run it. Not very fancy. Then it's going to define some bindings for the Windows API called crypt unprotect data. So this is basically the DP API in Windows, which allows you to encrypt things at rest, so that if you take out the disk, you cannot get the data, but allows to transparently decrypt it with the user's credentials. And let's see why they are doing that. Next thing, they are just looking at your browser's data. So they are looking at Chrome, Firefox, Opera, Brave, lots of different browsers, stealing your logins. Then doing the same for cookies, except that cookies are encrypted at rest in this cookies SQLite database. So they are then recrypting the encryption key that is encrypted with the DP API and basically decrypting that and sending all that to a Discord webhook. A few interesting things is that they are also looking at files in your downloads and documents folders with some keywords. So if they find any folder or file that matches some of these keywords, they zip it and they send it to this very legitimate gofile.io server. The interesting part is that it's also in French, MDP, Modepass. So maybe there are some, French victims or French threat actors. That's basically it. And so when we find that, a good way to pivot and to find more malware by the same person or with similar characteristics in 5 seconds is to use this dataset from PyPI. So you say, okay, show me all the packages from the same author. And here it's very simple because it's a specific name, but you can also filter on the description, on the user agent that was used to publish the package, things like that. And it also includes deleted packages that you do not find on PyPI. So here we just run the request and we find, I think there was 20 more from the same person with similar characteristics. So that's very straightforward and very useful. And sure enough, if we look at our cluster that we saw before, we see that all these packages belong to the same cluster, meaning that they are almost the same. I think here the similarity is 100% and sometimes like 99%. So this confirms that, if we find something new, we can just go ahead and look at where it is in the cluster and we don't have to redo the analysis again. In that case, if you just look at the source code on GitHub or on SourceGraph, it's a code search tool that works very, very nicely. You see actually that, it's a tool called the WASP stealer. So it's basically someone who took that, packaged it into the malicious package and used that. And we've seen that used quite a lot. So in summary, maybe because we are not going to discuss the 891 packages that are published right now, we see a lot of information stealers that are looking for your environment variables, your browser cookies. We see a lot of exfiltration through Discord webhooks, a lot of that. So maybe that's an interesting detection to build on your proxy. And a lot of dynamic evaluation, like something that basically does eval of base64 decode something. A lot of also second stages from somewhere else, from GitHub. So many pieces of code that are actually in the package are just downloaders. Most of the time, and also a lot of reuse of the WASP stealer and this thing that I'm not even going to try and spell out, multi-logger Python Discord, that basically steals your cookies and sends that to a Discord webhook. So a few resources if you're interested to dig into the topic. These are some very, very interesting papers. I know that papers are meant to be scary, but these ones are really nice to read. So they are very recent as well. I highly encourage to have a look. They are very, very great. And these are the other data sets that I know of. So there are a few on NPM, a few on PyPI. The Backstabber's Knife collection isn't public, but you can ask for the access to the person who publishes it. And the PyPI malware one is older. I think it hasn't been updated in 5 years, but that's some data point that can be useful as well. So Vlad, what's next in terms of research there and maybe for the tool itself?
Yes. So we are trying to double down on NPM continuous scanning. It's not as easy as PyPI because they don't provide those RSS feed. So we are actively working in getting there because NPM is where things happen. Not because the JavaScript ecosystem has problem per se, but because if you look at this graph at any time in history, it will look the same with the NPM ecosystem growing insanely faster than any other supply chain ecosystem for software building. So we want to get to NPM faster than later because we will find much more things. We have to develop new rules. We already have some. Feel free to help us on that. And the other thing is, this one is more speculative, but infrastructure as code is getting bigger and bigger. People are not provisioning their infrastructure by clicking in AWS UI anymore or on OVH UI. They are using infrastructure as code where the infrastructure is defined in a code base that is executed and that provisions servers, lambdas, by database and stuff. The Terraform ecosystem, which is one of the infrastructure as code solution, this ecosystem is not that big with only 13K packages in total. But when you execute this kind of stuff, you run it in a very privileged environment because you give it your admin credentials for your cloud infrastructure, whether this is Azure or AWS or others. So introducing malware in this ecosystem would be extremely scary and dangerous for the communities. There's not much literature about that yet. IAC is code. So let's consider it as such.
Yeah, and just as a short, I don't think there's any evidence yet of anything like that happening besides the security companies showing that you can do it. But maybe that will happen in the future. Something also that was released just yesterday by OpenAI is a new feature in GPT-4 that allows you to sandbox code. So basically, you can give it Python code, they execute it for you, and I think you can ask it for all sorts of questions. So it's in alpha right now, so we didn't have a chance to use it, but that could be a very fun way of doing dynamic analysis in a simple way. One way would be to say, when we get some results from Guarddog, we try to give the code to GPT-4, sandbox it, and see if it thinks it's malicious based on that. Something that we'd like to try as well is to see if we can train a machine learning model on a malicious package dataset. Unfortunately, there aren't that many. I think we could get to 2,000, 3,000, but not that much, and see if we can then confirm the Guarddog findings and classify, okay, we have this file that is supposed to be malicious. Is it malicious or not? That's for the future. And finally, it's an open source project, so.
Yeah, everyone is invited. We would love your contribution. We mark some of them as good first issues. There are false positives and false negatives in our rules and heuristics. We would love you to help us fixing that. And you can explore the dataset. Expand it if you find stuff. Please don't write malware. Be nice. But there's one more thing because we want to be fancy. We found that the other day. Do you want to describe this one?
Yeah, I mean, it's just a fun one. It's very basic code, it's like 35 lines of code. It's basically opening a reverse shell. The twist is that it's getting the port to where it opens the reverse shell from a TXT record in a DNS record. So the conclusion would be it's always DNS, even when it's not DNS.
And it's kind of smart because nobody really monitors what goes through DNS in an infrastructure. That's one of the best way to bypass a network protection is to use DNS. So very nice one.
Yeah, and I think here it's mostly for dynamic, when you change the port, mostly not bypass, but it was interesting to see nonetheless. So thanks a lot. The slides are here. The QR code is just going to the slides. We have some Guarddog stickers here, so please take them. Vlad isn't going to take them back with him.
No, and we are taking a few questions, I think, if we have time.
Yeah, thank you.
Yes.
And if there are any.
Okay, we have a few minutes for questions. Raise hand.
So thanks a lot for the talk. Question about, so the moment you decided to open source Guarddog, did you get yourself into a cats and mouse games with the malware creators? Is the maintenance cost of the rules?
I don't think malware's creators know that much about us yet. We are too small.
I don't think they care, mostly.
Yeah, and to be honest, I really think this person who published Fast API Toolkit was like, oh, I will publish malware. And 6 hours later, there were 2 blog posts because there is another company doing some stuff like us publishing, hey, there was a malware published today about that. So at the end of the day, yeah, it will get to a mouse and cat game. They don't care for now, so for now we are safe.
And do you have any experience with dynamic code analysis? Because all your presentations seem to be about static code analysis.
Yeah, no, so not so much. We didn't want to go this route. There is the project named Packagey that is doing that. I think they are doing some kind of dynamic analysis, lightweight. So not in a Docker container, not in a sandbox. I think they do some kind of hooking with S-Trace. So I'm not sure how secure it is if you run it on your machine, but no specific experience on that. Again, I'm very interested to see what comes out of this feature. If you could really give it some Python code and tell them, okay, give me all the DNS requests of the file write. It will be very interesting. So
we are working internally. Zach is working on some dynamic analysis for code. So that's a topic we are studying. For the Guarddoc scope, we just wanted this simple command that runs fast enough so people can put it in CI without removing it when they bang their head against the wall because their CI is getting slow and they are consuming all their GitHub action minutes.
And but also because, many people are doing sandboxing. It's not specific to a language. So if we build a sandbox, it would be like, mostly not as good as what everyone else is doing. So, yeah.
Any other questions?
Okay. All good. You've been
Thank
an
you,
amazing
Christophe.
crowd.
Thank you, Vladimir.
Thank you.